a DevRel at NetBird. So admittedly, I'm not a Nix expert, but I am a home labber who fell down the rabbit hole. And falling down the rabbit hole kind of allowed me to bring Nix to work and led to me using Nix to solve what I feel like is one of the hardest problems to solve in reproducible testing environments, which is networking. So this is just an idea of what's coming up. First, I'll go over my click moment and how the light bulb came on for me with Nix. Then I'll go over my two-phase approach to sneaking Nix in the back door of my company. And then I will kind of outline my future plans and wrap everything up. So before we get started, I think maybe I should just give an overview about what NetBird is for maybe people who are not familiar with it. So NetBird is an open source WireGuard mesh VPN. Generally, the preferred way is for peers to connect directly with each other. But we do have a management server control plane. Signal handles WebRTC signaling, and relay is the fallback when peers cannot successfully negotiate a peer-to-peer connection. And the peer-to-peer part is actually what makes the testing so tricky, but we'll get to that in a moment. So like many of you probably, I ran a home lab. And my kind of workflow was Docker Compose, Bash scripts, and pray. And for every new service, I ran the same 6 steps. Sometimes I tried to deceive myself into thinking I would maintain my Ansible playbooks. That never really lasted. But for every service, I followed the same 6 steps and encountered the same 6 opportunities to forget something or misconfigure something or just mess something up. So at some point, I saw the light and I switched to Nix for my home lab. And after a few iterations of my config, I didn't get there immediately, but after a few iterations, it finally clicked for me. And I think kind of what I can pick from my config that embodies that the most is my service definition. So in my services directory, I have a common function. And the common function basically takes a service definition and wires up everything needed to create a complete service. So when I create a service, I import that common function and I automatically get a DNS record in my Cloudflare account. Obviously, that record has a TLS certificate. I get a dashboard entry. I picture that at the bottom. My dashboard of choice currently is homepage, but other dashboard solutions are available. So an example here is Mealy. If you're not familiar with Mealy, Mealy is a recipe manager, and with one simple import and just enabling the service basically and giving my common function the port that the service runs on, I get all of the things I just described. The function does everything for me. And so I stopped thinking about what steps I needed to set up a service, and I started thinking about what a service actually is. I started to think the Nix way, where you define the inputs and the function handles the how. Given a set of inputs, give me this output. Now, I recognize where I am and the people I'm talking to. I know that thinking this way is probably as easy as drinking water for you guys, but I need you to understand how putting the functional paradigm in the context of infrastructure really allowed it to click for me and to have that aha moment and to have the tools in my arsenal necessary to explain this to other people unwilling or reluctant to learn it. So I ended up getting hired by NetBird last year in November, partly due to this Nix energy that I have. And I knew my mission immediately, and that was to evangelize Nix and NetBird. I knew that there were many problems at NetBird that could be solved with Nix, And I decided to approach this kind of evangelization in 2 phases, and I'll break down both phases for you now. So phase 1 was pretty straightforward. I had to bring NetBird's Nixpkgs modules in line with the current state of the client and management services. NetBird and their previous Nix evangelist sadly parted ways, rest in peace to a fallen brother. And the modules basically hadn't been updated since he left. So they were quite outdated, they were in quite a state. This would make me a first-time Nixpkgs contributor. And this was both very exciting and terrifying. So I'm not gonna lie, initially, I did take some heat from the Nixpkgs maintainers after my initial attempt. But in the process, I learned a lot and my PRs improved for the better. My instinct was to just give every upstream flag a typed option. And in my defense, this was how the module did things before. Basically, every flag in the NetBird client or the NetBird server had a typed option. So my thinking was, well, I just need more typed options for the options that are missing from new versions of NetBird. This was very wrong. The reviewer feedback was basically, your module shouldn't be a second source of truth for your upstream docs. And they pointed me to RFC 42. Structural settings. Provide escape hatches, not mirrors. You layer your options as environment variables on top of defaults and let Nix do the rest. This tension between completeness and maintainability is something that you all probably know very well, but for me, I had to learn this the hard way. So phase 1 was just packaging, a necessary but relatively routine step. Phase 2 is where NetBird and Nix gets truly interesting, in my opinion. So the problem with testing different networking setups is that there are so many different variables and conditions to consider when you're trying to pinpoint an issue. If you have 2 clients behind EasyNet, then they're probably going to negotiate a peer-to-peer connection, no problem. But if you put one of those clients behind a restrictive or carrier-grade NAT, then they're probably going to be relayed. Now, if you multiply those variations with different client versions, different server versions, different OSs, different network conditions, maybe different MTUs, then you can kind of imagine the mess of variables that we need to track and test in a reproducible way. So traditional CI flows would spin up VMs, run the tests, and hope that the environment is representative. And so more than actual confidence, all this produces is the daddy of all it runs on my machines. Now, the natural reaction might be, not of these people in this room, probably, but of most people in tech would be just Docker compose it, bro. But for NetBird, this doesn't work for a number of reasons. One being that NetBird on Linux, the NetBird client on Linux, for example, uses kernel WireGuard, not user space WireGuard. NetBird wants to be your DNS client if you're running the client, because NetBird can do all kinds of fancy things with automatically redirecting host names to IPs. So we needed a proper kernel and we needed a real networking stack. So we have this kind of cacophony of test scenarios, and I realized this kind of problem is kind of exactly what Nix is good at and what Nix can solve for me very easily. We have the same outputs for every test, given the same inputs. If you describe a network topology as a Nix expression, you can get an identical test environment on every machine, every time. And unlike Docker, VMs run on their own kernel. When NetBird creates a WireGuard interface in the VM, it's real. when a packet hits a NAT, it's a real net filter. It's not IP tables, it's not some shared kernel shenanigans. And so every test dimension, whether it be NAT type, client version, OS version, is a function. And functions, as we know, compose. So the whole test environment basically can become a derivation. You can cache it, you can share it across CI runners, you can diff them against another topology. It's a value, it's not a process anymore. So I looked at this problem and said, has Nix been waiting for this problem? Or has this problem been waiting for Nix? And my colleagues, they rolled their eyes, thinking, here he goes again. But I knew I was onto something. Now, a lot of you maybe will have noticed a couple of glaring issues with my perfect solution. So I'll try and break those down for you now. The first issue is something that I encountered pretty early in my home lab journey. And that is that Nix doesn't really have a way to do VMs declaratively very well. So I went all in on Nix modules in my home lab, but sometimes you still need a VM. Home Assistant, for example, unless you want to have 2 billion dependencies, you probably want to run it in a VM and not via the Nix module. So I noticed pretty quickly in my Nix journey that Nix was lacking in this regard, and even community-made like libvirt wrappers didn't feel Nixy enough to me. And solutions like micro-Nix VM, obviously, as the name implies, only really works for NixOS VMs. So I wrote my own solution. It's just a very simple QEMU wrapper. So I define my cloud image source, I give the hash, define a format, CPU type, memory, and give a cloud init config if I want to do that. And it will basically create a QEMU service of that VM. It will automatically download the image. If it needs to be decompressed, it will do that, and it will convert it to whatever format I specify. So I had this module already ready in my back pocket. Cloud init support was obviously going to be very helpful for me in this use case. I had CAL support, so I could have ephemeral disks for my VMs. So even though it was built for a home lab use case, with a few relatively minor additions, it would be ready for ephemeral VM test usage. Problem number 2, being the Nix guy. Stop me if you've seen this one before. A problem arises and you think, man, Nix would be awesome for solving this. You raise your hand, grinning from ear to ear, and watch your colleagues mentally shut down in real time because they already know what you're about to say and they're sick of it. There's no point in building a perfect testing solution if you're the only person who's going to use and maintain it. You need your team to be on board too. And this is why I spent so much time earlier detailing my home lab journey and the click moment that I had. Because seeing the functional paradigm build infrastructure was a lot more intuitive for me than seeing it build a string. And it gave me the aha moment I needed to be able to confidently break down the paradigm in an easily digestible and in an easily digestible way that just kind of seems to make sense, more so than the alternatives. So when I explain Nix and this solution in particular to the team, I don't start with syntax. I just start with very simple natural thinking like, what are the things? What is a test scenario? It's nodes, it's a topology, and it's a few assertions. That's really it. A node, if we drill down further, what is that? A node is just an OS, some software, and a network interface. A NAT type, What is that? How do we break that down? Well, that's pretty simple. A NAT type is basically just a router with some firewall rules. It's really not that complex if you think about it in this way. And this maps more directly to how you would think about this problem if you were whiteboarding it. The difference is that in Nix, the whiteboard description is the implementation. If anything, this is the more natural way to approach this problem. So when it starts clicking for your team members and you say things like, same inputs, same results, it runs on my Mac, it runs on your Linux laptop, or define what things are, compose them, and the system builds itself, then congratulations, my friends. You've officially done the impossible. You have made Nix sound appealing to a non-Nix user. So this is what a scenario looks like. I don't know how well you can see it on this screen, but I'll try and explain it for you. It's just YAML, basically. So it's easily readable by anyone on the team, even someone who wasn't drawn in by your Nix Captain America speech. So all I do is define the nodes, I boot them, I run some commands, and assert things work. Then I collect the diagnostics. In this example, client 2's IP gets resolved automatically, the runner handles it, and assert, in this case, just means this command must exit 0. If it doesn't, the test fails, artifacts get collected. Notice there's nothing really Nix specific here. All the Nix magic happens in the implementation. So your Go engineer can write and read this, and that's kind of the point. So behind the scenes, Nix takes that YAML that I just showed you, and it takes the node definitions and builds a self-contained bundle. Everything is there. The runner, the scenario, the VMs, bootable VMs, for every node that you've specified, it's all there. Every binary, config file, and kernel modules gets pinned to a hash. So your teammate runs the Nix build, gets the exact same store path as you, and gets the exact same result. So that's the deal. The team writes the scenarios in YAML, Nix handles reproducibility. They don't need to learn Nix to use it, but they'll start to understand what's happening and become more capable of contributing to the tool if they do. And if you've drawn them in with your explanation, hopefully they will want to learn Nix. Okay, so in the future, plans I have to improve this tool and expand it. I guess number one on my list of priorities would be to have tests run as build steps. Currently, the build kind of spits out an artifact and you have to run that yourself. But if tests were to run as a build step, then the test itself could become a derivation. We could automatically cache test results, which means that basically once a test runs once, you know the result, you never have to run it again. Also, one cool thing I think would be achievable is to have, maybe on GitHub, for example, if you have your issues section on your GitHub comply to a template, then a user fills in the template, a CI would pass it, it would generate a test scenario, and it would run automatically. And then the result of that scenario would become a early kind of diagnostic signal before an engineer even dives into any code or tries to diagnose the issue themselves. There's also maybe a cool community angle here. I try to keep that on myself as a DevRel, where you could maybe have community members submit their own weird, exotic networking environments as modules. And you could run those. Anyone could run those. You could add them to your list of tests. And because we're in the age we're in, I feel like I have to give a mandatory AI-related idea. So you could have, from sources other than GitHub, some kind of LLM maybe parsing user issues, and writing their own kind of Nix expressions to represent test scenarios that we don't currently have in our repertoire. So, yay AI. And I will finish on kind of like a selfish plug note. Obviously, I have developed these new schemes and ways to sneakily make my colleagues accept NixOS, but I could always use some help. So if you'd like to join me and solve some of these problems, if they sound interesting to you, then that could be us.